All right, so we're going to keep going on lesson 4-4, Factoring Quadratic Expressions. This is part 2. Before we get started, I want to repeat something that I said a long time ago. Same sign add, opposite sign subtract, keep the sign of the bigger number. That will come into play when we do one of the methods for factoring. So remember that. Same sign add, opposite sign subtract, keep the sign of the bigger number. So in this section, we're going to factor trinomials. In the last section, we did 4-term polynomials, and we factored by grouping. This time, we're going to use a couple methods, and we're going to factor, and it's going to end up looking like this up here, where in the beginning, we would FOIL this and end up with a trinomial. Well, in this section, we're going to start with this trinomial and hopefully end up with the two binomials next to each other. So here's another easy one. I'm going to write a little bit more out for this one because it's going to lead into some of the harder ones that we'll do in a minute. All right, so we can start out with our two parentheses because it's x squared. So I can still put my x here and my x here. All right, but over here I'm going to write negative 72. This is your L. They have to multiply to negative 72, which means they have to be opposite signs, but I'm not going to put the signs in yet. So I'm just going to write down the different factors of 72. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 5 doesn't go into 72, 6 times 12, 7 doesn't go into 72, and then 8 times 9. And then I would already have the 9, so I don't keep going. All right, so since this is a negative 72, these would have to be opposite signs. And if you remember back to that second slide, it said same sign add, opposite sign subtract, keep the sign of the bigger number. So this time we're going to have to subtract to make 14, and it's a positive 14, so the bigger number had to be a positive, and you'll see that my factors right here will make 14. So I can put the negative 4 up here, the positive 18, and it's factored. On those first couple of examples, I totally forgot to tell you that, hey, we're supposed to GCF first. We got lucky because none of those had a greatest common factor. But then we get to a problem like this, and there are a couple of rules in factoring trinomials. The first rule is you can't factor it when the x squared is negative. So that's one of the things that we have to fix before we do anything. And then when you're done, you can't have a fraction in one of the parentheses. There's no fractions in the factors. You'll see that in a little bit. So let's go to this one. I have a negative in front of the x squared. How can I fix that? I don't have an equal sign, so I can't make the negative go away by dividing both sides by -1. But I can take the -1 out and put it in front of parentheses, and then just divide everything by that -1, which is really just changing all the signs. And by the way, that is factored. It's just not factored completely. But what I would suggest to you guys is when you do have a GCF, go to where you're going to write the answer, put the GCF in front of two parentheses. This way you're not going to lose credit for making a silly mistake of forgetting to write down the GCF when you're done. All right, so now I'm back to this. This guy right here is what I'm trying to factor now, okay? So we're gonna go ahead and I'm gonna put the two sets of parentheses. Because that's x squared, I can go ahead and put the x in the x. I have the 12. Write down all the ways to make 12. This time I want to add, because it's a positive 12, to make a negative 13. So I see that 1 and 12 will work, but 1 and 12 make positive 13, so I have to throw some negatives in front of them. And there's my two guys. I put them -1, -12, and then I can write them down here where I'm going to put my answer. And there we factored it. Here we have an example where the a is no longer a 1. That makes it a little bit more difficult, not much, but a little bit. And I'm going to show you a couple of different ways to do problems like this. The first way is called the AC method. So what we want to do is we want to multiply the A and the C together, and that's going to give us a positive 24, right? And this is a personal thing for me as a teacher. I want to see you guys write some more stuff down here. To get a positive 24, what kind of numbers do you have to multiply together? Well, they're going to have the same sign. So I like to see that written as part of your work. Well, when we have same sign, we add things together. All right, and then we put a line here, and then we just start listing all the ways to make 24. And I do 1 and 24, 2 and 12, 3 and 8, 4 and 6. All right, so I have the right sets of numbers. Now I got to make that middle term, the B. Well, this is what makes the middle term. But it needs to be an 11x. So I'm going to put an x with it here and an x with it here. And I have to make a positive 11, so these are going to be plus signs. Now, 3x plus 8x is 11x. So I'm going to take out this 11x. I'm going to replace it with that binomial, 2x squared plus 3x plus 8x plus 12. Okay, so here we have a problem that looks very intimidating from the beginning. Okay, so sometimes we're going to go ahead and forget some of the things that we learned earlier in the year, and we're just going to go, hey, I should do this the AC method, and we're going to multiply 48 and 18 and get a humongous number. Most math teachers are not that mean, and it's kind of a dead giveaway that if you multiply your A and your C and you get a really large number, that you probably missed a GCF somewhere along the way. So let's go ahead and do the GCF on this. As you do that, you should take out a 6, an X, and a Y. That's a funky looking X right there. Remember, GCF is just a division problem, so that would make 8x squared minus 10x minus 3. All right, that's a good start. That's factored. I would come down here to where you're going to write your answer and put 6xy on the outside and then 2 sets of parentheses that we'll fill in later. And then you don't have to worry about the 6xy anymore. All right, so we're going to do this the AC method. So let's go ahead and multiply the A and the C together. That's going to give us a negative 24. To multiply two things to get negative 24, they have to be opposite signs. Well, if we have opposite signs, we should be subtracting terms to make the middle term. So now I'm going to write down all my factors. There they are. And they have to subtract down to make 10. If you notice, this makes a 10 and this makes a 10. All right, so this is one of those, there's a couple of different kinds out there that are real tricky, so you gotta be careful. That's why I have you write down this stuff up here, because if you see that you have to subtract, well, 4 and 6 do not subtract to 10, so it has to be the 2 and the 12. So remember, I wanna make an X, so I'm gonna put X's with these guys. And I want it to be a negative 10, so that would have to be a negative, which means the 2 has to be positive. So I'm going to go back and I'm going to take the 10 out and put in the 2x minus 12x minus 3. Now you could have switched that up. You could have put negative 12x first and then the 2x second. It doesn't matter. All right, so now I'm going to box that stuff off. There we go. And I'm going to GCF both those guys. I'm going to take the 2x here, take it out, put 4x. Now I'll have some students stop right there and say, okay, it's 2x times 4x, because they take the 2x out and think it's a subtraction problem and they made a 0. This is a division problem. You can never make a 0 with division unless there's already a 0 there. All right, so what is 2x divided by 2x? That's plus 1. So if that one's 4x plus 1, this one has to be 4x plus 1 also. So what do I have to factor out of negative 12 and negative 3 to make a 4 and a 1? Well, that would be negative 3. So now I have my factors that I could write out here. One of them gets to be 4x plus 1, and the other one gets to be the leftovers of 2x minus 3. Don't stop there. Make sure you go down to where you're going to write your answer. And there you go. So it was an ugly problem to start, but it wasn't too bad. All right, so here is our last one. I'm going to do this one a little bit different. I'm going to do this one called the modified AC method. That's what I call it. I don't know if it really has a name. If you had a couple other teachers in the past couple of years, they might have called it the slip and slide. I'm a high school teacher, so I have a hard time calling it slip and slide, so I'm going to call it modified AC method. All right, but it starts out the same way. We have to GCF this thing, and I believe we can take out a 4, an x, nope, no x's. We can take out a 4y squared, leaving 6x squared plus 19x minus 7. All right, so that kind of looks ugly, but I'm going to go down here. I'm going to put 4y squared. All right, so now all I have to worry about is this guy. All right, so the modified AC method is a little bit different. I'm going to move the 6 down to the 7. So, because I don't really want this 6x squared to be a 6x squared, I just want it to be x squared. So if I move it down to the 7, I'm still doing the a times the c. That gives me negative 42, right? So now this is like one of the first ones we did. That hopefully is pretty easy because I can put an x there and an x there. So now I'm trying to figure out 42. Well, that's 1 and 42, 2 and 21. And I go, oh, wait a minute. 2 and 21 looks like it works. So I'm going to put a 2 here, 21 here, positive 19. So that has to be a positive 21 and negative 2. The only problem with this method is that a lot of students will stop right here because they figured they factored. But remember, I wanted you to factor that. If you do FOIL from this parentheses, you're not going to get a 6x squared or a 7 at the end. So why is that? Well, we kind of broke the rules a little bit by moving the 6. So we gotta fix that and put the 6 back in to one of these parentheses. Well, I don't know which one it goes into. So personally, I'm going to put it into both of the parentheses, right? And I put it in as a fraction. And then I'm going to rewrite it simplified. X minus 1/3 and x plus 7/2, right? But then I go back to the beginning of this slide, and there was a couple of rules. I can't have a negative in front of my x squared, and I can't have a fraction in my factor. And both of these have fractions. But if you remember quite a while ago when we were talking about taking numbers out of parentheses, it was a 2-step process. It was change the sign and divide by the number in front of the x. Well, a division sign is a divided by, which kind of tells you that I must have divided by 3. Well, if I divided by 3, it came from in front of the x. So I'm going to take these and I'm going to slide them in front of the x, hence the slip and slide stuff that they talked about. So this becomes 3x minus 1 and 2x plus 7. And that's the modified AC method way. I don't care which way you like more. Pick one, get good at it, and we'll be fine.